So these alcohols, longest chain, type of bonds, OL at the end. We'll do some more with it. These are just practice. Next type of functional group coming off the longest chain is going to be something called an organic acid. Okay, organic acids. Organic acids are going to be written like this, COOH, or drawn as, here's your R group. Any number of carbons, could be 1, could be 200, doesn't matter. And you have a double bond to an oxygen with another bond to an OH. So it has an alcohol group, and it has a double bond to an oxygen. All right, so the H and then the N help dissociates in water. The shorter the R chain, the stronger the acid. So in other words, if it's only 1 carbon, it's going to be really strong. If it has 20, it's going to be less strong in terms of concentration and what it can do. All right, here is your quick naming deal. So I would definitely look, here's what you're kind of looking for in a molecule. Let's see if it's an organic acid. You're going to change the ending to oic acid. That's all I really got to do. You just got to name it and change your ending to oic acid. So let's say we have 4 carbons, and at the end carbon, it has to be on the end carbons. Can't be on the middles because there's not enough bonds. So you have something like that. Remember, there's hydrogens here. At the end of the lines, I'm not going to draw them in. 4 carbons, this means it's a bute. Single bonds, it's an ane. Okay? Because there's this little deal, butanoic acid. All right, hopefully that helps out. Next one, we got aldehydes. A-D, A-L, D, E-L, H-Y-D-E. Aldehydes. Aldehydes are going to look something like this, where they have at the end of a molecule, just a double bond to an oxygen like that. Could be written like this. Not written OH, okay, it's HO, because they're 2 separate bonds, they're not together. And all you need to do for these, for ALs, when you name them, is have an AL ending. So let's do our 4 carbons, like we did before, and now we have a double bond to an oxygen with an H hanging off of it. And remember, there's H's off of all of these. I'm not going to draw them, but they are there. Still 4, it's bute, it's single bond, so it's ane, it's a butanol. Okay, butanol. A couple other molecules we're going to talk about. These first ones up here on top, these are called ketones. Here's our R group again. So somewhere in the middle of the molecule, somewhere you're going to have a double bond to an oxygen off a carbon. All right, remember, any number of carbons for the R groups. And here's how you're going to name this thing. You got to have the suffix of O-N-E, and you got to tell me what carbon it comes off of. So let's go with, let's say there's 5. Let's say off this one I have a double bond to my oxygen. Remember, there's hydrogens hanging off of here. Oops, that's not supposed to be there, sorry. But we just don't write them down. All right, so what goes on here is now we have 1, 2, 3, 4, 5. 5 is a pent. Single bonds, ane, and because it has a double bond to an oxygen, it's pentanone, which means you have a double bond to oxygen. Tell me the location. From right to left, it's off the second. So it's 2 pentanone. This 2 tells me the location of the double bond or the ketone. All right, next one is going to be called an ether. All right, ether basically have a sandwiched oxygen. They have an oxygen in the middle of a bunch of carbons. So what you do is you basically name one side, name the other, okay? And then just put ether at the end. So here's what you're going to run into. You could run into something like this, oxygen here, and then go 1, 2, 3. Remember, there's hydrogens attached. I didn't draw them. So name this first side. You normally go with the shorter side or alphabetical. So this one's going to be eth, because there's 2 carbons. So it's an ethyl. And then you have the other side, prop, and ethyl. Whoa, I did not spell that right at all. Ethyl, propyl, ether. Ethyl, 2 carbons. Propyl, 3 carbons. Ether, an oxygen in between those propyl and ether groups. Eth is 2, prop is 3 carbons. There it goes. All right, and the last one for this one is going to be an ester. Okay, esters basically have sandwiched oxygen and a double bond. It's going to be written something like that, COO in between some carbons. These are going to be the nice, flavorful or smelly molecules, like jelly bellies. When they have that scents and those flavors, those are esters. They make those. So they can be synthesized to make artificial fragrances. A lot are responsible for how things smell. How it's going to work out is this. Is basically what you do is you name one side and name the other. So let's say we go 1, 2, and then we have our double bond to an oxygen, and then we have our sandwiched oxygen, like that. Okay, remember there's hydrogens here, which I'm not going to draw, but they're there. So what we do is we name the side that doesn't have the double bond to the oxygen, so we name this side, that's 2, so that's an ethyl, okay? Ethyl, 3 carbons, prop, ethyl propyl, ethyl propyl ester. And there we go. All right, so we got those. Looks pretty good to me. But I think, yep, I'm thinking right. It's not ethyl propyl. It should be ethyl propanoate. The OAT ending is key. Okay, so ethyl propanoate. Shortest chain without double bond to the carbon, so it'd be this side, and the 3, and then it's attached to the oxygen. And you should be pretty good. So let's quick review a couple so we know what's going on. Here's a couple. Here's an organic acid. How do you know it's an organic acid? Because of the COOH double bond here on the end of the molecule. 3 carbons, 1, 2, 3. Propanoic acid, oic acid. Next one, this one is an ester. Why? Because it's this and this, a sandwiched oxygen and a double bond. All right, and how you name this one, name the side that doesn't have a double bond, so it's going to be propyl. Here's my propyl. And then I have a 1 carbon, that's methanoate. Okay, propyl methanoate. Next one, here's the family is an ether because it's a sandwiched oxygen. It's ether, so we get the name really either side, but usually we go alphabetical. So we go methyl, because that becomes for propyl, and then ether. And the last one, this one is a ketone. Why? Because it's somewhere in the middle carbons, the interior carbons, has a double bond to an oxygen. All right, and because it has that, there's 4 carbons, so it's a bute, and it's an one, ketone, butanone. Do I need to say where it is? No, but it's got to be on one of these two. Either way, it's going to be the second one from this side in, or the second one from this side in, because remember, you can count from left to right or right to left. Shortest number wins. All right, so there's your basic functional groups. We'll get into some more drawings and practice later. Hopefully this helped you out.